All right, so today we talked about the real number system. We talked about how that's the entire number system as we know it. And we focused on the fact that the real number system is like an umbrella. It divides into two pieces, rational and irrational. And we compared that to words we know in life. Like if you're being irrational, then you're not listening right. You're not performing right. You're being a little weird, right? But if you're being rational, you're thinking straight, you're making good comments. Same in math. Rational numbers are the ones that can be written as a fraction. They're decimals that terminate and they're decimals that repeat, nice and clean. The original rational type of number is our counting numbers when we were little kids. 1, 2, 3, 4. Then we learned whole numbers like 0, 1, 2, 3, 4. And then we learned integers because, whoa, there's negatives in our life now. But when we started dealing with fractions and decimals, we realized that they're also rational. So anything that can be written as a fraction, that terminates or repeats, that uses bar notation, remember that term, that's what that line is over our decimal, cannot have a denominator of 0. Because if it has a denominator of 0, then it's no solution. It would be irrational. Our irrational, these are our weirdos. They don't fit the mold. They do different things. These cannot be written as a fraction. And if they are a fraction, they don't repeat and they don't terminate. So our most famous is pi, or any decimal that doesn't have a pattern to it. And connecting it to yesterday's lesson, it's not our perfect squares. So any radical that is not a perfect square is irrational, like the square root of 10, or the square root of 99, or the square root of 56. Those are all irrational because they're not perfect squares. Now, because we learned all these definitions, we have an issue in math that we come in contact with that you may not even realize is an issue. So let's say I give you the decimal or repeater, 0.3. It's our most famous one, right? What's the fraction for 0.3 repeating? 1/3. You know that because you've memorized it. What if I asked you to change 0.3 repeating into a fraction and show me how you got it? Initial reaction is, okay, I know how to do that. I have 0.3. It is in the tenths place. So I'm going to put it over 10 and I get 3/10. So I'm just going to go ahead and I'm going to simplify it and it'll become 1/3. 3 goes into 10 how many times? It doesn't. This is simplified. Is this the same thing as 1/3? No, it's not. So our traditional way to get a decimal to a fraction does not work with repeating decimals. So we have to have a clear-cut method, and the only way that we can do it is through algebra. So flip over your notes to this page, and we're going to change repeating decimals to fractions. So we're going to use 0.2 as our reference. And so 0.2, it says step 1, make the repeating decimal equal to the variable n and write 4-digit spaces of your decimal. So look what they did. They wrote n equals 0.2222. They just wrote 4 spaces. Now I put the invisible 1 there because I wanted to have that number there when I do the math. So I just wrote it in. Step 2 says to take this that we just wrote and multiply both sides by 10 and write it down. So 10 times 1n is 10n. And 10 times this is this. All I did was move the decimal over to be exact. Then it says to subtract the original thing I wrote from that. So I do. 10 minus 1 is 9n. And this minus this is 2.0. Guys, y'all remember with subtracting decimals, the decimals have to be lined up. When I do that, I get this. And when I solve this simple one-step equation by dividing by 9, look what I get. 2/9. There's the repeating fraction. So let's go back to 1/3 and model it. It's our most famous one. We know the answer has to be 1/3. So if we have this, and we know the answer has to be 1/3, let's see if we can get it using the steps they just told us. So I'm going to take 0.3 and I'm going to make it equal to 1n, and I'm going to put how many spaces? 4. So I just write 4 3s. Then it says to multiply both sides by 10. So it becomes 10n equals 3.333. All it is moving the decimal one place this direction. Then it says to subtract this. So I'm going to subtract 1n equals, I got to make sure they're lined up. So I'm going to subtract, what's 10 minus 1? 9. And this cancels, cancels, cancels. 3 is what's left. So I divide by 9. N equals 3/9. That's not 1/3, is it? Yes, it is when it's reduced. Now here's a clue, and I'm telling you this just to help you. If you're on a test and you're stuck, all of these repeating decimals, 99% of the time, are over 9. So if you can't remember this and you're on a test, put the fraction over the decimal over 9. So for instance, if I have 0.65 repeating, put it over 99 and reduce it. If I have 0.6 repeating, put it over 9 and reduce it. Look, there's the answer. 2/3 repeating is a repeating decimal, so we know it worked. So you can use that as kind of like a quick method if you're stuck or if you need a quick answer. It doesn't work 100% of the time. It works 99% of the time. Now, how many times did I tell you you're going to see this year? Probably once. So it's going to be something that when you have to do it, you're going to have to look it up on the internet and see how to do it again. I do every time. Okay?